In the world of civil engineering, ensuring the strength and stability of structures is paramount. One crucial technique employed to achieve this is beam lapping. Beam lapping involves the overlapping of reinforcement bars, commonly known as rebar, within a concrete beam. This practice is essential for maintaining structural integrity and effectively transferring loads throughout the structure. Understanding the principles and importance of beam lapping is vital for any civil engineer involved in construction projects. Beam lapping becomes necessary due to the limitations in the length of commercially available rebar. While beams often require longer lengths of reinforcement, rebar is typically supplied in standard lengths of 12 meters. To overcome this, engineers employ lapping techniques to seamlessly connect these shorter rebar segments, creating a continuous reinforcement system within the concrete beam. This ensures that the forces acting on the beam are distributed evenly and that the structural integrity of the beam is not compromised. The importance of beam lapping cannot be overstated. It plays a critical role in preventing stress concentrations at the points where rebar segments meet. Without proper lapping, these points would become weak points in the structure, susceptible to cracking and failure under load. By overlapping the rebar, the stress is distributed over a larger area, reducing the risk of localized failures. This is essential for ensuring the long-term durability and safety of the structure. In essence, beam lapping is a fundamental technique in reinforced concrete construction. It allows engineers to overcome the limitations of rebar length while maintaining the strength and stability of beams. By understanding the principles and best practices of beam lapping, civil engineers can ensure the construction of safe and durable structures. The process of beam lapping, while seemingly straightforward, involves careful planning and execution to ensure its effectiveness. It begins with the accurate calculation of the required lap length. This length, determined by factors such as the diameter of the rebar, the grade of concrete used, and the anticipated load on the beam, dictates the extent to which the rebar segments must overlap. Determining the correct lap length is crucial, as an insufficient overlap can lead to structural weakness, while an excessive overlap can result in unnecessary material usage and increased construction costs. Once the lap length is determined, the rebar segments are positioned according to the design specifications. The overlapping sections are then securely bound together using steel wire. This binding ensures that the rebar segments act as a single unit, effectively transferring the load between them. The entire assembly is then encased in concrete, which upon hardening forms a composite material with the reinforcement, providing the beam with its characteristic strength and load-bearing capacity. The significance of lap length in beam lapping cannot be overemphasized. It directly influences the strength and effectiveness of the lapped joint. A lap length that is too short may not provide sufficient area for the transfer of forces between the rebar segments. This can lead to slippage between the bars, reducing the overall strength of the beam and potentially leading to structural failure. Conversely, an excessively long lap length, while not detrimental to the strength, can lead to increased material costs and construction time. Therefore, determining the appropriate lap length is a critical step in the beam lapping process. It requires a thorough understanding of structural engineering principles, material properties, and design codes. By accurately calculating and implementing the correct lap length, engineers can ensure the creation of strong, durable, and safe concrete structures. Alright, so when it comes to best practices, it's really important to always start with a thorough site assessment. You want to understand the soil, the climate, and any potential challenges that might come up. And don't forget, using high-quality materials can make a huge difference in the longevity of your project. Now let's talk about some alternative techniques. One method that's gaining popularity is the use of recycled materials. Not only is this more sustainable, but it can also reduce costs. Another technique to consider is modular construction, which can save time and improve efficiency on site. Moving on to common mistakes, one of the biggest errors is poor planning. Skipping the planning phase can lead to unexpected issues and costly fixes down the line. Another common mistake is neglecting regular maintenance. Even the best-built structures need upkeep to remain in good condition. In conclusion, always remember that a successful project hinges on careful planning, quality materials, and regular maintenance. By following best practices and considering alternative techniques, you can achieve great results. Thanks for joining us.